In this video, we're asked to write a method called add, which will basically add the node values of two individual trees. For example, we have a first tree here, which has 1, 4, and 7, and then a second tree, which has 2, 3, and 1. And you can see that the overall tree will be a cumulative sum of these two values here. So 1 plus 2 equals 3, 4 plus 3 equals 7, 7 plus 1 equals 8. But what happens in the case that the two trees are not identical in shape? Well, in that case, what we're going to be doing is we're going to take a look at the first tree, which has the values 6, 2, and 8, and we're going to fill in the missing branches here that come with tree number 2 here. So for example, we do our cumulative algorithm here where we say 6 plus 1 equals 7 for the top root. Then the left branch, 2 plus 4 equals 6. But notice that we have a new branch on the right side of the overall root, which is going to contain the value 5, and that comes from our tree number 2. So, and the same thing goes for the 2 on this side here. So let's get started. So what do we know? We know that we're going to be adding two trees, and basically from the spec it looked like we wanted to change our first tree to be the cumulative sum. Sum. I can't spell. So alright, so let's get started. So one thing that we do know is that for every public method in an int tree node class, we need a private helper method. So without further ado, let's start writing this stuff. So we're gonna call our method add, and it's gonna take in a parameter, which is just gonna be an int tree, because we're just taking in another tree, and we need something to compare it to. So how are we going to do this? Well, from what we wanted before, we wanted to change the first tree to be equivalent to a new tree that's the summation of the first tree plus the other tree that we're comparing it to. So we need to use the principle called x equals change of x, which just basically means we're going to be changing the value of x in the end. So the way we're going to do this is we're going to say our overall root is going to be equivalent to our add method, and it's going to take in two parameters. First of all, our overall root itself, and then we're going to take the other int tree, and we're going to call its overall root. That's how we get out of that loophole there. Okay, so now we're in the private helper method. So what is our return type going to be? Well, our return type is going to be, we're going to return just another int tree. Well, an int tree node, because we're changing our overall root when we actually look at it. But that will eventually change our tree. So let's get started here. It's going to be a private int tree node, and it's add. It's going to take in an int tree node, and we're going to call that first root. And then it's going to take in a second int tree node. Got a little excited there. Oh, yeah, there we go. And we're going to call that second root. Second root. Okay. So what do we actually want to look at here? Well, given the spec, notice that the right side of the of our first branch was null, but the right side of the second tree wasn't null. So we ended up adding that bit. So that tells us one thing right off the bat. We want to look at the second tree first to see if it still has values. And the way we're going to do that is we're going to say, okay, if our second root is not equivalent to null, then let's do some stuff. So what's the stuff we want to do? Well, in this, we do have a special case to consider. What if it just so happens that our first root has no value in it, and it's just empty? Well, in that case, we want to declare a new int tree node. And we're basically going to say, okay, so first root is going to be equal to this new int tree node. And we're going to store the value 0 in it, just because it doesn't have any data at that point. So this is where we get into our cumulative sum, and we're going to say, okay, oops, whoa, a little sloppy there. No. Okay, this is where we want to get into the data values and start changing them. So the way we're going to do that, we're just going to say first root dot data, access its data field. We're going to make sure that its data is a cumulative sum of the addition of root2 dot data. Okay, that's good. Next part we want to do is we want to traverse left side and then traverse right side. So the way we're going to do that is we're going to say first root dot left is equivalent to our add method, and we're going to take in the first root dot left and then the second root dot right as the parameters there. And then what we'll do is we'll do the same thing for the whoa, whoops. I misspoke there. We're going to traverse down the left side of the second root as well, because we want to make sure we're looking at all the values at the same. We want to make sure if we're traversing the left side of one tree, we're doing the same on the other. So for the first root dot right, you guys can pretty much assume that it's going to be the same thing, and it just so happens that it is. So root dot right. Now let's close off the if statement here. And at the end, we need to add our return type, and our return type is in tree nodes, so we're actually going to be returning and changing our root in the overall end. So that's it. See you guys in the next video.